Okay, so it said number 2 said round to 3 significant digits. You are going to see these kinds of questions again because they will be on your test for sure for this unit. It says round to 3 significant digits. So you can only have 3 numbers in your answer. The funny thing about this, or not funny really, I guess, but it said 3 and then people were giving me 2. So make sure you read the question. Don't rush so quickly that you don't actually understand what the question is. So we need to keep 3 numbers. So you look at the 4th number, the one that's to be dropped. It's a 5 with stuff after it. So your rules, old rules for rounding with 5s hold. So this would be 3.86. The next one is 256,000. Some of you only gave me 3 numbers in your answer, but not the correct value. You gave me 256 or 257. We want to keep 3 numbers, so you look at the number to be dropped, which is the 7. It's higher than 5, so it rounds up the 6. So 257 is the 3 numbers you keep. You either stick 3 zeros behind them, or scientific notation. But don't change something from a couple of 100,000 to a couple of hundred, okay? It doesn't work like that in life. If it does, I wouldn't, I'd be poor. Okay, so put the following numbers in scientific notation. You need to use all significant digits. It doesn't say anything about significant digits. It just says scientific notation. So you keep all of them. All of those numbers are significant. You can only have 1 number in front of the decimal place. It's a number that is less than 1, so it's going to be a negative, and we had to move the decimal 3 places. So you have to keep all of them.
Wait, why do you have to keep the numbers? Like all of them?
Because it doesn't say round to 2,
Oh.
right? It doesn't say round.
If it doesn't say that, then you put all the numbers?
You got to put them all in, okay? The next one, ten to the 2. Okay, so this one has to get rounded to the tenths. You've got a 5 with nothing after it. The previous number is odd, so you round it to make it even. Next one, 1562 divided by 3. Multiplication and division. You can only have 1 significant digit in your final answer, because 3 only has 1 sig fig. So the only number that you can keep is the 5. You're going to have to take another look at that question. Okay. Do I need to do the next one? No. So the next one, C can only have 2 sig figs. And then the last one has to be rounded off to 1 decimal place. to know the dollar per person. Do we have any information up there that's got dollars in it? Ben?
Price per pizza.
The price per pizza. We know that it's $12.99 a pizza. Mackenzie, this is pretty tricky. It's $12.99 per pizza. So we've got the dollar sign where we want it. We want it on top. Do we want pizza in our final ratio? Do we want dollar? We want dollars per person. There's no pizza there. So we want to get rid of pizza. The only thing you do with this math, when you set it up, is you multiply. Each ratio that you use, or each value that you use when you set it up, just has a multiplication sign in it. So, if I want to get rid of pizza, I need the value that has pizza on it on the top. We know we've got 4 pizzas, so I'm going to multiply this by 4 pizzas. Now, pizzas will cancel. Not the 4, but the pizzas will cancel. Did I get to dollar per person? Nope. So I've still got to find people or persons. Do I have a quantity about the number of people? I do. I know how many people I have. The number 6 is really 6 over 1. I can invert that and make it 1 out of 6. The value that you get is different, but the relationship is the same. We're going to be using ratios. Anytime you have something over something else, it's a ratio. And we manipulate them so that they do what we want them to do. You don't change the relationship itself, but you change how you use it. So if I want people to be on the bottom, 3 people is like 3 people over 1. So 1 over 3 people. Any number, 75, is 75 over 1. 100 million is 100 million over 1. You can set it up as a ratio. Any number divided by 1 is the same value. So now, if I look at my units, I've got dollars over people, which is what I want, right? Another word for people is persons. So I've got 3 people. So what you do on your calculator now is you take any number that's on top and you multiply. Any number that's on the bottom, you divide. So what's 4 times $12.99 divided by 3? 1732. No, 4's on top. There's 4 pizzas. Okay, so yesterday you could already tell me, some of you could already tell me what the price was per person. This is how you would actually show it. Let's do another question like this. Now,
Yeah, it's 4 pounds. I'll put money on it.
Now, the answer isn't important. Can you show your work?
It's 4.
It's 4.
I was thinking 200 cookies, not 400 cookies.
What do we want to find?
How many pounds of butter?
Pounds of butter. We want to find pounds of butter that we need. LB means pounds, by the way. Okay, so we need how many pounds of butter? What do we need? We know that half a pound makes 50 cookies. And we need to make 400 cookies. If we want our answer to just be this, you're going to find whatever value, whatever relationship has pounds in it, and then make sure pounds is on top. So do we have that in the next two values? Is it on top? Yes. We've got a half a pound over 50 cookies. So we don't want 50 cookies, so you take your ratio here and you multiply it by the cookies so that the cookies cancel. So you've got 0.5 times 400 divided by 50. Five goes into 40 8 times, and a half of 8 is 4. 4 pounds of butter. 5 goes into 40 8 times. I dropped the zeros. And then I took a half of 8, and that's 4.
You have to put it like that.
You're going, when you do dimensional analysis in this unit, you're going to set them up as ratios. Okay?
Put like 400 divided by 50 times 1.
3.30 moles of ammonia times 10 to the 23. What are the particles? Because we're talking about ammonia. What are the particles? Matthew? Molecules. This is why I've been writing this as molecules over 1 mole. Okay. So take your calculator. What is 6.02 times 10 to the 23rd times 3.3? Janae? 1.986. 6.
Times 10. It's always 24. And then,
Okay. So we've got the number of molecules. Because that is an answer, you would round that. Don't write this down yet. So that's the answer for molecules. You don't write as big as I do. So this, you wouldn't have reached the right side of your page yet. It wants the number of total atoms in that number of moles. How many total atoms are there in a molecule of ammonia? How many atoms altogether? Ethan? NH3. How many? 4 atoms. So you would take your unrounded number and you would multiply it by 4 atoms for every one molecule. Molecules cancel. My unit left is atoms. So take that number, multiply it by 4. Or is it 7.96? About? No formulas required. You don't have to rearrange any formula to get the answer. You just use your units on your quantities to drive the math. But you always set it up as a times. Each number is multiplied by the previous number. So if you want to copy that down, no, what's the particle for Avogadro's number when we're dealing with the element iron? We use atoms. So there's the only information that we have. So you always start with a quantity that has the units that you're looking for on top. So we're going to use Avogadro's ratio first. We want to get rid of moles because we only want atoms. So there must be a quantity that has moles in it. So now moles are going to cancel. We have our quantity that we want, so we're finished. So it's 6.02 times 10 to the 23 times 0.0718 divided by 1.
I got 4.32 times 10 to the 5.
So what did you get?
4.32 times 10
To the power of
to the 22.
22?
Yeah, adding this. Just write FE after.
Should.
Okay.
Atomic mass units. It's so small that they came up with its own unit, okay? And it's called an atomic mass unit because it's the mass of an atom. The short form for that is AMU. We usually shorten it even further to U. So atomic mass units, sometimes you'll see in textbook or references, AMU, 12.01 AMU. Or they'll put 12.01 U. One atom of carbon-12 has a mass of 12.00 atomic mass units, or 12.00 U. 1 mole of carbon-12, 6.02 times 10 to the 23 atoms, has a mass of 12.00 grams. 1 mole of an element has a mass in grams with the same numerical value as the mass of one atom in atomic mass units. But they're very different quantities because we're talking 1 atom versus 6 sextillion atoms, okay? So when you look at the periodic table, name an element, any element. Nitrogen, everybody find nitrogen. What is the mass given in the periodic table? Point. Okay, so nitrogen, 14.01. If we're talking about a mole, we're talking about grams. If we're talking about one atom, we're talking atomic mass units, okay? So the number in your periodic table is going to be the same numerical value, but your unit will change depending on if you're talking about atoms or a mole of atoms. Two very different quantities of atoms. The mass of 1 mole of a substance is called the molar mass. The mass of a mole. Its symbol is a large M, and the units are grams per mole. You can write that as grams per 1 mole as well. So grams per mole are the units. So the molar mass of a compound is the sum of the molar masses of each element. So H2O. There's 3 elements in here. Sorry, 3 atoms, 2 different elements. So you find the mass of each element, multiply it by how many atoms there are, and then we add them up. So the molar mass of water. What is the molar mass of hydrogen?
1.01 grams per mole.
Yeah, it's 1.01, but there's 2 of them. What's the molar mass of oxygen? Trinity, oxygen. Find it. .00. So the molar mass of 1 mole of water molecules is 18.02 grams per mole. All of your molar masses on your periodic table are reporting to 2 decimal places. So every molar mass for your compound should have 2 decimal places. Okay? All the answers. Okay. Carbon dioxide. Molar mass of carbon. Nope. 0.01. The molar mass of oxygen, still 16. There's 2 of them. So the molar mass, .01 grams per mole. Sodium chloride. What's the molar mass of sodium in your periodic table? Aaliyah? 22.99. Chlorine? Do you remember that demo I did at the front where we did the mass before versus the mass after? This is why. Every atom has mass. So that's why the mass did not change, because we had the same number of atoms before and after. Okay? I don't think that was even Mr. Simon. Okay. The amount of a substance, moles, the mass, and the molar mass are related to each other through the equation N is equal to mass divided by molar mass. So this means, what's the unit for mass? Grams. So basically we've got grams divided by grams per mole. And that would give us moles. So there's your units. So this is another equation that we're gonna use. But if you like dimensional analysis, you're gonna use that. So big M is molar mass. Units are grams per mole. Small m is mass in grams, and small n is still moles. Yes? Okay, I'll do it at the top of the next page. Okay. If you were going to use the triangle, all right. A typical can of cola contains 40 grams of sucrose. What formula do you have for sucrose there? Okay. Calculate the amount of sucrose in 40 grams. So, they give us mass is 40 grams. It wants to know the amount of sucrose, so we're looking for a number of moles. Often in these questions, they won't give you molar mass. They'll either give you the name of the compound or they'll give you the chemical formula. You have to figure it out. So we know we need the molar mass for sucrose. So we have to figure that out. There's 12 carbons, 22 hydrogens, and 11 oxygens. So 12.01 times 12, 1.01 times 22, bless you, and 16.00 times 11. So it's 342.34 grams per mole. So we're going to do this two ways. I'll show you formulas and I'll show you dimensional analysis. You pick the way you're comfortable with, okay? You're going to pick which way you're comfortable with. Hopefully you'll get more comfortable with dimensional analysis. Okay. So now I know molar mass. I want to find N, so it's mass divided by molar mass. So it's 40 grams divided by 342.34 grams per mole. Zero point 11684 moles. How many significant digits can we have in our final answer? Always look at your initial data first. 3, correct. So 0.117 mole. So that's how many moles of sugar there are, of sucrose there are in our can of cola. If you were going to do this using dimensional analysis, you would have to start with a quantity that has moles in it. Which value inside that red box has moles in it? Matthew? The molar mass. The quantity that you're looking for has to be on the top. So you take the molar mass and you invert it. Can I change this now? So you take the molar mass, and so I've got 1 mole contains 342.34 grams. I just took my molar mass as a ratio and turned it upside down. The relationship is still the same. Now I'm going to multiply that by 40 grams. That will get rid of my units. Grams, I'm left with moles. That's the only step you have to do. So you end up with 1 times 40 divided by 342.34. No formula required. The nice thing about this is there are no intermediate steps, so there are no rounding errors. Okay. Next question. Read the question, identify what symbol we're given in the question. So, Ben, what do they give us?
They give us more.
They give us moles. Do they give us anything else?
A liter.
They tell us that we've got a liter of blood.
Contains 4 nanomole glucose with C6H12O6.
So our blood glucose level is 4.0 millimoles. Calculate the mass of this amount of glucose. We're looking for small m. So we know millimoles. We know it's glucose, and we know we want mass. So we need to figure out the molar mass of glucose first. So once you've calculated the molar mass, you can start your question. If you are going to do, how many of you think you might stick to dimensional analysis? How many of you think you might stick to formulas for now? Okay. So, there's one other ratio that you need for this question. Because our molar mass is grams per mole and our moles is millimoles. So we also know that there's 1,000 millimoles in 1 mole. I'm going to do dimensional analysis first this time. What is the unit of the quantity that we're looking for? The unit. We're looking for mass, so what unit do we want? Matthew? We want grams. So, do we have grams in any of these quantities that are circled? Aaliyah? Yeah, we know we have 180.18 grams for every 1 mole. Okay, you're not going to use that value again. You've used it once, it's done. Out of the 2 numbers, the 2 quantities that are left, do we have moles? Junaid?
We do have 4.0 millimoles, but do we convert to 4,000?
Ah, we don't even have to do that. Do we have moles in the other value?
And that,
That one, right?
yeah.
Can I use it like that in the next step, or do I have to flip it? Yeah, you have to flip it so you can cancel the 1 mole. So now moles are gone, but I'm left with millimoles. I want to get rid of that. So I use my last value. Put it on top so it cancels. So in my calculator, I would have 180.18 times 4 divided by 1,000. Why didn't I say that again? Why?
How do you know what order to do?
I pick the quantity, out of these 3 quantities, I pick the one that's going to give my final unit that I want. I want grams on the top.
So how do you know when you put in your calculator what order to do?
Well, it doesn't really matter what order. Like you could do 4 times
Good morning,
180.
folks. Here are your morning announcements for Wednesday, November 15th, 2017. Cafeteria. Take advantage of the
Yep, you can
November
do that.
limited time offer and get a large cinnamon bun with a small milk for $2.25. The specials today are pasta bake and panzerotti. Recycling today.
Okay, we're not finished. Formulas. Some people like formulas. So,
Apex Driving. Apex Driving will be at Westwood today at noon. Stop by to see how you can get your license 4 months early.
I'm going to do it on the
Sign up
next
now to save the
page.
spot over the Christmas break.
This one you do have to convert millimoles to moles first. This one, you have to rearrange to solve for what your unknown is.
Music. Rehearsal for the Santa Claus parade is today at lunch. Open mic is also tomorrow at lunch, and so is rehearsal tomorrow at lunch. Students in locker 2433, please report to the main office.
So convert to moles first. You will get the same answer. Okay, you'll get the same answer. Okay, homework. Aw, not bad. Aw, it's first period. I want you to do questions 1.
How many times do you want us to do?
1 to 2.
1, 3, and 4. 1, 3, and 4. Tomorrow in class, you're going to be doing the rest of them. 1, 3, and 4 tonight.
Sorry, I can't hear. Sorry.